Let's start streaming. And that was previously. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac and try that. We're live now. We just got a black screen. I might just go get the Mac.
We got a lot of members. We don't know if you feel comfortable giving someone who gets to turn in papers funding.
okay.
Okay,
Okay, everybody can see. Okay, so recording that. Almost nothing set up on this Mac. That's the only downside, which is fine. Okay. Well, first we can check to see if our YouTube looks correct. So we'll go ahead and do that. We're live now. 2 are watching. It might be. Let's see here. I think it is. So let's oops. Let's see here. Now there is a horrible lag. Stop streaming. There's a horrible lag. Let's just power. Now there is a horrible lag. Stop. Stop. We got echoes too. Okay. All right. So this is what we look like. Let's see if we can get the YouTube to eventually catch up here in the middle. So this is what we look like. Hey, all right. Okay. We're heading in the right direction. It looks like we're maximizing our use of YouTube real estate. Almost. Hey, all right. Okay. We're heading in the right direction. Looks like we're maximizing our use of real estate. It might be wrong. I mean, I'm just fascinated with the infinite delay there. Okay. All right. 15 minutes later, we finally got the streaming working. Maybe nobody's watching at all, but we're hoping somebody will. There's two, but that could have been the other one, because I had that one open as well.
Well, I think when you had that, it went up to 3 and then it went down.
It could be. Okay, so that's good. That's right. Please subscribe.
Did we get the stream sponsored?
I'm going more for the free of charge. Personally, I think that's right. You could, but then you don't get no credits, and then it affects the graduation. Okay. Okay. So now that we know that that's working, I'm going to go ahead and quit that. And we're going to go to the syllabus. All right. So I feel like I'm trying too many different things at the same time, but it can be fun and exciting that way. We're going to be trying GitHub and WordPress and my own website on the UAF page for hosting projects. So let me go ahead and get the syllabus up and going. How many are in the undergrad class? We got 3, 4 in undergrad class, and I guess 2 in the graduate. Is that correct? Does that sound about right? No?
I'm not registered yet.
Oh, not registered yet, but you're going to do undergrad.
Yeah.
Okay, so we have 1 graduate student. Hooray, okay, and then the rest are undergraduate students. Okay, that is important because the graduate students, of course, have more work and have to pay more, so you really will have to, pay more, through the course load. I'm going to open up the graduate one. So, as you guys probably know, I'm really big on Visual Studio Code, and I have to be honest, been agonizing over, oops, did that wrong, but that's okay. Been agonizing whether I should do C++ or whether I should continue on with the whole JavaScript, TypeScript that I started in the springtime, and partially that's because my main graphics rendering engine is written in C++. But on the other hand, I'm having a lot of fun doing the web stuff because you can just get that immediate feedback. People don't need to sorry. People don't need to install your software. They can just go to a web page. The power of ShaderToy kind of shows what you can do exactly on the web, which is really it's pretty limitless. You're just kind of limited with the version of the shading language you can use. But like I said, being able to pick up your phone or not require people to install software is a big plus. Plus, you don't have to do things like writing graphical user interfaces. You can just use all the power of the internet to do that. So yeah, I'm kind of undecided there. So, but let's go ahead and open up the graduate syllabus, and I'll go ahead and kind of talk about what's different with that. I want thumbnails. Okay. Resize this. Okay. Okay, so this is there's two syllabus or syllabi. One is for the grad students, one is for the undergrad students. First of all, let me welcome you to the computer graphics rendering course. This is a hybrid course, and what that essentially means is that on Tuesdays we're going to have in-class session, an hour and a half, and Thursday is the hybrid part where you'll work through like a class activity online, and I'm experimenting using this screencasting software called Viddle on an iPad, so I can basically kind of, you know, scribble out the notes and talk over it and put it out on the internet. And the idea there is you can kind of compress everything. So obviously during a lecture there's a lot of downtime because we're talking, we're discussing, we're just kind of finagling our way through the slides or whatever the case is. And so screencasting is kind of a way to like compress it. So the idea is I don't want you guys to have to sit through 90-minute video listening to me talk. I'd rather we're gonna have short videos with an activity thing so you guys can work your way through the homework and learn the material. I think that by far doing graphics is a far better teacher than me just sitting up or standing up here and just talking to you all day long about it. And so that's basically what we want to do in this class. We have three main goals, okay? And the first goal is we're going to learn about ray tracing. Then we're going to do real-time rendering, and then we're going to focus on physically based rendering. Okay, so essentially what we want to do is understand what this equation is in those three contexts. Okay, so we're doing ray tracing first because it's harder, and because it'll challenge you to kind of work on what is one of the most important topics right now in computer graphics. Everybody at SIGGRAPH last year, which is the special interest group in computer graphics, you had over 16,000 people attend. This is all the guys who make the movies, all the guys who make the games, essentially, and they're all talking real-time ray tracing, right? Because NVIDIA is pushing real-time ray tracing, buy RTX cards, and so the big push, sorry, the big push right now is ray tracing. So I thought when I taught this class last year in the springtime, I focused more on real-time rendering first, and then we kind of dabbled in ray tracing a little bit towards the end, but we didn't really do that much with it. So we're gonna start out swinging. We're gonna start out swinging, doing ray tracing first, and then we'll go to real-time rendering. So we'll talk about shadows and stuff. All right. So let's just quickly go over the main difference for the grad students real quick, and then we'll talk about all the different hybrid topics. Okay. So I was kind of coming up with a grading concept on what should differentiate grad student work from undergrad student work, and by far the biggest thing that we look to grad students for is the novelty of the idea. So the idea is you're trying to come up with something new, right? It's not just like a more advanced version of what an undergrad student's working on, but the idea is let's work on creating something new. So that's something that the grad student, I guess I can't use plural unless maybe I can. So the idea is you're kind of working towards research, and the idea is coming up with a new idea. And then secondly, there's some additional homework assignments to work on because we want to also focus on proficiency. The good news, and we'll talk about that in just a little bit, is that hopefully the homeworks will be fun and there's some choice involved on your part. Okay, so let's get into the hybrid topics. Okay, so essentially this is the plan right now. It's probably an ambitious plan, but it's the plan. So I'm basically going to create these like mini class activities for you guys to work out for Thursday. So I'll have it posted before Thursday comes around. So for the first week, we're going to focus on a computer graphics crash course. So I do not require that you've taken computer graphics in this class before. And basically, we're just going to learn everything you need to do to get OpenGL going. Okay. And next week, we'll talk about the ray tracing algorithm, how it works. Then the following week, we're going to continue ray tracing and talk about sign distance functions, because these are pretty interesting mathematical utilities that tell you basically, are you inside or outside an object, and how far away are you? And that's useful for modeling a lot of interesting things. And then the following week, we're going to talk about how to use physically based sky models. So I always wondered as a student, hey, how do we make sky, right? Is it just blue? Or is there some other like better way of doing it? So I'm going to talk to you about physically based sky models. A lot of times when you get out of this class and you decide to do graphics, chances are you're not going to write a ray tracer from scratch. You're going to use something else. So I wanted to introduce you guys to one that I like. It's called Corona Renderer, because it's a physically based ray tracer, and you can get a demo for free and we can play around with it. And so there'll be an exercise around using a commercial ray tracer to kind of test out different settings and what they do. Then we'll talk about bidirectional reflectance distribution functions, BRDFs, and that's basically getting into how do we accurately model reflection or refraction. So we'll talk about that. Then we'll talk about Monte Carlo methods. Specifically, there's lots of different ways to do this, and so I'll just introduce you, how many random ways are there to throw darts and get a picture out, essentially, and we'll learn how there's, of course, just throwing them randomly, but then there's systematic ways of doing it so you get the right image faster, okay? And then we'll start talking about bounding volume hierarchies. So essentially, it's just sticking larger objects to represent lots of smaller objects, and it's faster to kind of go filter out those large objects first, so you can kind of increase the speed there. Talk about web-based graphics stuff. So we're going to start basically transitioning into how to use our real-time renderer, basically. Because ray tracing, we can basically do everything with one shader, and you don't have to do anything else. And then we'll talk about post-processing methods. So those are like motion blur, depth of field, some advanced camera type techniques. And then we'll talk about, if we have time, I don't know if we're going to have time to get to this, but creative synthesis, procedural generation, maybe some miscellaneous topics. All right. And then you can read this on your own, but this is basically the course outcomes. And so the idea is, here's what you should know when you're finished with the course. And we'll take a look at this later if we have some time. Let's see here. I'm going to talk about the grading and the course policies in just a little bit. In fact, actually, the course policies is going to be, you can read that on your own, because I basically just copy-pasted everything that UAF says I have to put in there, which easily adds 3.5 pages, I guess, or 3 pages worth of stuff. This is stuff you probably already know, that's already on the website. In fact, I make these using LaTeX, the syllabi, and I just have an input file that's got the same information for everything. So, so you guys, if you've been in one class this semester, you just have to read the section once, getting the same information for the other classes. Okay, so schedule. Okay, so here's the idea here. 15 weeks goes pretty quick. All right, and there's a few things. So we're gonna have 2 tests. The midterm and the final will be take-home exams. So I kind of like those because you can kind of learn, I guess, if you will. So it's like your last-ditch effort to learn stuff. And then you'll see there's 8 homework projects. Okay, but I'll explain that. There's actually just a few that are required. So approximately the 3rd week of the class, you guys are going to pitch your projects, and those are your those are your research projects, so what you plan on working on. And there'll be a research paper and a midterm update, so you can kind of talk about here's how your project's doing, and then at the end we'll have a week set aside for doing your final presentations, so you can kind of talk about how everything went. Okay, so let's go ahead and talk about the homework. Okay, so 2 exams, several homework assignments, a research project. This is pretty typical. We're going to use Slack for our for online communication. So I'll have Slack. I have Slack installed. I'm going to monitor it. So it's a good way to get in touch with me, or just to talk amongst yourselves. And so, like any good online class, there's some mandatory participation, but hopefully it'll be fun. And the idea here is it's basically like class participation. Okay, so here's how the homework's going to work. Okay, so there's 4 required homeworks. So let's go down here. So the required homework assignments are ray tracer, a real-time renderer, shadow maps, and post-processing. So those are the 4 things, minimally speaking, that's kind of covering what we're really focusing as far as class material goes. And this is the only one that's kind of from scratch is the ray tracer, but the other ones are you're kind of working from some base code to kind of start out with. All right, and then the student's choice. So if you're an undergrad student, you'll work on 2 of these, and if you're a grad student, you'll pick 4 of them. So the choices there, you can do like a video documentary, so you can like do a little short recording of like, oh, I'm going to explain what BRDFs are, or I'm going to explain what this technique is. Okay, and you can repeat that once. Creative synthesis, I always think that one's a fun one. Procedural generation, generating textures, material. Debug tools, hey, chances are you might want to write a debug tool, so this homework assignment's almost like right up your alley. Stencil shadows, that's a good option for if you want to explore the other side of shadow mapping, or I guess the other side of real-time rendering, stencil shadows. Global illumination, which is a topic I really like, but that basically has to do with let's not focus on just the light that hits a surface and gets to our eye. Let's talk about the light that hits other surfaces before it gets to our eye. And then lastly, a video game based on an approved theme. So if you like making games, then you can also repeat that one additional time. So if this is something that's kind of like your thing, you can like have fun making games. Now, at the end, we're going to have this could be kind of like combined with the other class, the game demo scene competition. And basically what that is we'll have a theme, and we'll make a game, and then we'll kind of we'll watch everybody's games and see how that goes. So this might be I'm still deciding if I want to hold this in conjunction with another pre-existing game competition. So I'm still thinking about that one, but that is one of the homework assignments. And I probably need to fix that because it is one of the required homework assignments. But it's kind of like at the end. Okay, now the research project. Okay, so the idea here is basically working on a research paper. And if you're a grad student, now the undergrads are less intense than this. It's like 4.5 pages, a few less journal citations. But the idea here is that I want you to spend a lot of time doing the background research on the topic you want, and that way you kind of have a good understanding of why it's a good problem to work on. Okay, and for grad students, we want to work on something new. So this is so if you want to work on shadow maps, we want to work on like a new concept for shadow maps, or it could also be nobody's done a recent survey of different techniques for doing shadow maps, or different stuff like that. So like I said, novelty is kind of a big thing for grad students. So I kind of want to spend time doing there. And then you'll see like there's hundreds and hundreds of points here. And the idea is, I was like, okay, that might be, normally I just set aside like a few points here. I thought, hey, what if we just like, just make that number big? So we'll see how that goes. But the idea here is, this is just a regular research paper. Introduce your topic, talk about the previous work that's been done, describe the problem you're trying to solve, talk about how you solved it, what your results and analysis are, and then talk about what you basically said in the paper and what you would like to work on in the future. So this is just a normal normal research paper, and then the pitch will be like a 1-minute presentation of what you want to work on, and the midterm project report, that'll be like a 5-minute presentation, and the final report will be a 7-minute presentation. So just something really short to talk about what you want to do. And I'll have a nice timer so you guys can time yourself. That's really big if you go to a conference. You know, if you only have 10 minutes or 20 minutes to talk, then that's all you get. Otherwise, you're out of there. So I'm going to try and we can practice on that, right? Because sometimes you get up here and it's hard. Sometimes you start talking about your topic, and then 2 minutes in, you're like, oh, now I'm starting to get going, and I'm like, wait, I only have 3 minutes to go. Otherwise, what ends up happening is you take 10 minutes, right? So we're gonna practice on getting the timing down a little bit on the presentations. Okay, and let's see here. The last thing for the grad students is, and I guess the grad students there's only one, but you get a special task that you'll get to present the results or a method of research. So basically find a research paper. I know, he's like, maybe I should downgrade. It's actually, it shouldn't be too bad, right? Because if you're doing your research and you've read the paper, you should be able to talk about it. Okay, so the idea here is that every week, now don't worry, it's up to 2. Okay, so you're not going to be pummeled every week. Like I thought, I thought, if you had a class and you had 10 students, then every student's not going to be able to talk 2 times, right? But if you had like a class with just 1 student, I don't want them to think like you have to teach, a class every single week for 10, 15 weeks straight. That wouldn't be fair. So I decided we'll max that out at 2, and then that gives you a chance to kind of talk about research, as you might be expected to do, right? If you're a grad student, you graduate, you end up being a project lead or something, and you got to talk to your team about the work you guys are doing that week, or so it's additional work, but it's work that you would be expected to do, I would hope, in the real world, right? Just being in that participation. So lots of experience. So if you look at the undergrad, obviously it'll feel like a lot less information, but the biggest difference between the undergrad one and the graduate one has to do with the way that I grade the homework assignments. Okay, so essentially it's pass or fail if the program runs, right? So that's just like a yes. Okay, you get credit because your program runs. Yes, you included your source code and a screenshot of what your thing looks like. Your project page includes a description. So this is like, minimally speaking, these things should be on there. And then 100 points, if for when I evaluate it, does your program have some kind of interaction to it? Secondly, is it correct? So, right, so if you say you're going to do Phong shading and then it looks like toon shading, I'm really like, nope. Yeah, it's kind of like not getting what you promised. And then lastly is novelty. So like I said, for grad students, are you making something new, or is this just something like anybody you could find anywhere, right? So the difference between let's open up the undergrad one. You'll see that basically interaction you get for undergrads. I spend more time like, what is the interaction like with your program, and a little bit less on novelty, right? So essentially, I'm gonna 80%, I'm just, for undergrad project, I'm looking for, is it correct? And does it have an interaction that lets me, play with it and see what you're doing? And then lastly, just a little bit, is it new? And then for grad student, spending more emphasis on if it's new versus the interaction, because I figure as a grad student you have more experience doing things like interaction, so it's less important to me. Okay. The idea, so just to kind of get I'm expecting the homework assignments. The first homework assignment might be intensive, but the other homework assignments I don't think will take more than one night of effort, right? 4 hours-ish or so, 4 or 5 hours. Even the game thing, I do this thing called 1 hour game jam, and I like challenge myself. Can I make something in like an hour or 2 hours? So you can kind of go from scratch and build something up that meets what I'm looking for without requiring like a whole weekend's worth of work, okay? And that's the idea with the homework assignments. So we're trying to learn this stuff, but we're not trying to kill ourselves over it as well, okay? Yeah, you'll see over here on the undergrads, 4.5 pages, 5 journal articles, one new entry, and having 5 citations on a research paper is not bad. It's not bad. Do you have any questions so far? The syllabus always takes forever, I think. They want us to make them long, I guess. Okay, so let's talk about all the different websites. I may get sick of this and be like, we're just doing 1 or 2. But for now, we got a lot. Okay, so the one website is the GitHub. So this is where I'm going to host all the source code, and I'll probably put all the lectures on here as well, and the links to the kind of the main information. And then this particular one, the rendering course, is part of this program called Epic, which I'm taking as an instructor to kind of develop online courses. So we actually are going to be using a WordPress site as part of that. So let me click on that. So this will actually be like the centerpiece, what we'll be using for getting your homework assignments, getting all the lectures and everything. So you'll definitely want to bookmark this page, or you could bookmark the GitHub because it'll have links to everything. But essentially, this will have like the posts and everything. So I'm trying it out. The idea is to kind of make something that's like kind of sleek and just kind of like, let's just learn the material. Okay, so I'm kind of building this out, and this will have all the activities and stuff that you'll be using alongside the YouTube stuff that I'll be posting. Okay, starting with the computer graphics crash course, which I'm still developing, but basically this will have all the information, what we're basically going to be doing here. Okay, so there's the WordPress site. Then if you need information about me, or if you need a link to all the courses, this has everything, my office hours. So basically Tuesday and Thursday it'll be 5:10 to 6 p.m. or you can talk to me after class, and Thursday from 10 to 2, so right there in the middle of the day, and Wednesday by appointment. I'll probably be here most Wednesdays, but I'm not going to guarantee that I'll be here per se, but I'll probably be here most Wednesdays. Let's see here. This has links to all the current courses and the previous courses. All right, so that's the instructor website. And then I haven't uploaded this yet, but I can show you more or less what it's going to look like. If you've, I'll open up the last year's course. So basically, this is where we're going to host all the websites, all of your homework projects. So I think we might do a vote and see if you guys would rather use C++, Python, or JavaScript for all this. But the idea here is that you would do like over here. So all your homework is posted on here, and then we basically can I can quickly get to it, and then you can see what everybody else is working on, which I think is exciting. This also helps you find out who is the person in the class to go ask if you have questions on that in particular. So plus it's nice to have a place where you can kind of host your work. Okay, so that's what we're going to do there. Okay, and then I need to put a link to Slack. Okay, let's see here. Are there any questions so far?
I think I'll be on like 8 Slack teams after this or something. 8 to 9 Slack teams.
Well, see, the one we have, now I don't know if I have it on here. Maybe I do, but excuse me. It's on the other computer. Well, I might be able to get to it. It's like computer graphics, AI. I don't know. I'll look for it later because I don't want to spend too much time on that. Okay, so the first thing we're doing this week is the crash course. Okay, so I guess since you all are here, we can kind of maybe feel out pros and cons of which language we should settle on. And I'm totally open to JavaScript or TypeScript, Python, because the AI class is going to be using Python, C++. The only problem with C++ essentially is it's there's no guarantee that your code will compile. Like it's supposed to be, modern ISO C++, but there's no guarantee that you can send me C++ code and it'll work, right? Especially since I know the school people have an affinity for using Linux or Mac. What's up?
What compiler do you use? G++?
My favorite compiler is the Microsoft compiler, Visual Studio.
That's the only one that's not really standards compliant and seems to have issues.
But it works best. The debugger. Now, somebody on Twitter actually said that debugging should be like a last resort kind of thing. Like, they kind of almost made it sound like it should be this obsolete concept. And I'm like, I don't know about that. But now, if you have the right settings on the Visual Studio compiler, in other words, if you're doing experimental stuff, it's not going to work, right? That's true with any of them, because I'm trying to cross-compile stuff to work on Linux right now with the GCC compilers. And then I know if I use the Mac, I mean I got to use Clang, and it's a completely different concept. It has like what's more. I find that more important than the compiler you're using is the IDE you're using, because that really dictates your interaction with the language, right? So if you're debugging code, it's going to be a different experience in Xcode versus GDB versus the Visual Studio. And so I'm just used to the Visual Studio way of doing it. So it's not that there's any like wrong way of doing it, but there's no guarantee, right? If you send me C++ code, there's no guarantee necessarily that I can just like compile it and run it. You would hope that would work, but even the build system, right? You give me a bunch of C++ code. Is it a Makefile? Is it an Xcode project? Is it a Visual Studio solution? Is it?
But if you just give the CPP files, you should be able to do
Right. But with the graphics program, putting everything in one CPP file is dangerous because you have to have vector classes and matrix classes and camera classes.
What
and
I'm saying, even if it's multiple CPP files, you should just be stupid with more than 2 CPUs.
But you're gonna wanna link it to
Yeah,
a
that's
window,
right. So
something.
that's when you know your build tools. Like if you give me a bunch of C++ files, and if I'm using G++, I should know how to link OpenGL with G++. You guys are in 400 level.
But you're
computer
gonna
science
wanna
class, you
use
should
like
know how to link
SFML or
stuff.
GLFW or
Yeah.
whatever.
I'm just saying.
Yeah, it's more challenging. Like if this was an algorithms class and you were like, okay, go ahead and write me a data structure for doing a binary tree. That's probably something you're using cout for and cin, right? To do use input and output, you know, like your interactions on the console for an algorithms class. But for a graphics class, yeah, it does. Which toolkit are you using? Are you using, you know, you could be using GLFW, FreeGlut.
Let's just write bits to the VGA buffer.
You could write bits to you know, write to OXA0000, you know.
Python's just gonna work in theory, right? Because you can just like import the library, you can just go import the OpenGL library and then like Vector takes care of everything.
So, anyways, my point is C++ is I'm hesitant to jump on there because of its the portability issue. It should be portable, but getting it to work on every computer takes work. So, I'm leaning against that. I could be talked into doing your graphics projects in like Unity or something like that, where you do kind of have this cross-platform build ability. The only problem with Unity is that, or that I sense, is that a project that should be like measured in kilobytes is starting to be measured in tens of megabytes. That's the only thing I'm a little bit worried about there. But I am open to that idea if you guys would like to do that.
Also, I don't want to spend like 10 hours setting up this complex like, system on Linux.
So, can you describe like the Python and JavaScript? What we would be
Sure.
doing those?
Okay, so my personal thing is that I think JavaScript and TypeScript are easy to make cross-platform applications that work on your phone or whatever. And I'm leaning towards that's the best way to do it. But I know with like graphics, you know, if you're still thinking about C++, like there's that appeal because it's just it's speed. You guys are familiar with C++, but anyways, JavaScript. So just as an example, right? Let's go ahead and write a. We'll go ahead and start a new file. Index.html, sure, and okay, so I'm going to go ahead and just let's create a new canvas. So we're going to create an element, canvas, and let's go and add the canvas to it, and let's just set the width of the canvas to 640, and let's set the height to say 480, and then let's get a WebGL context. And let's set the clear color to red. And let's just clear the color buffer bit and the depth buffer bit. Okay. Where's the terminal? I like using Node, and look, you got graphics on this, like instantly, like in just a few minutes, and it works everywhere. And so this is the big thing here. If you use JavaScript, then it's fast.
You can install libraries.
What's that?
You don't need to install libraries.
There's no libraries, and I already have matrix code and vector code and things like that we can use. I mean, for the first part of the class, we're going to spend working with GLSL, writing a ray tracer, because like if we go to shadertoy.com, here's what can be done with sure, we'll pick this one. Okay, so you can do very nice graphics in a web browser without needing to like mess with anything special. Okay, so there's that appeal to it, and then we can spend our time focusing on learning the GLSL code, which we're going to use this to do ray tracer anyways initially. So really the first part of everything is just getting up to speed. So I think maybe, and Python's not too far away from this in terms of, you know, it'll normally just work. Like we'll settle on a library for doing graphics, so that's an option. But I think maybe JavaScript or TypeScript might be maybe the easiest one, you know, when it comes to just, you know, getting it to work. But I don't want to also, and I'm not opposed to C++, but there's challenges, right? There's the, we'll probably just have to pick one platform, and then that's, or I could just get it all running, get a Linux box running, and, which, I have a bunch of ARM-based Linux boxes running Ubuntu that if you target your code towards that, we could also just say, well, if it runs on a Raspberry Pi, then we're good. Like we could do that. So at this point we need to figure out, should we go the C++ route? It's dangerous, but exciting, right? JavaScript, which is probably I feel it's got the least number of obstacles, right? You just work with a text editor and you're on your way. And then the other ones they got, you know, they're kind of in the middle somewhere. What are you guys' thoughts?
I would like to learn C++ and stuff, and like OpenGL and everything, but like you said, there are like those problems. So
Well, even if you're doing JavaScript, like using WebGL, the interface is basically the same, right? As your
Yeah.
OpenGL.
It's not bad. I mean, for the longest time, I did graphics in C++. I can write a GLUT program without no manual necessary. Like just, yeah, at almost about the same amount of time. We could also do that as well, but it is a little more challenging because of. I'm okay with it, but maybe we'd have to settle on a platform for that. All right, so maybe we'll do raise of hands. How many people would like to do C++, despite the naysaying? I've been talking this whole time about C++ and nobody even raised their hands. There's just no interest at all. None?
You compare it to other
I know he wants to do.
Was ever the right choice.
I know he wants to do Rust. Well, I picked C++ because
Well, the thing is also like C++ is all a bit taught, so I want to learn languages.
yeah. So there's either a lot of C++ hatred in the room, but
I'm sick of doing it.
they'd rather it be Rusty instead. You know, it's
Graphics in Rust is still kind of like the problem with a lot, like OpenGL, for example, is I think is that the interfaces that OpenGL has doesn't work well with Rust's like ownership concepts and stuff. And so I think they're right now like it's in development basically, like graphics libraries that have an interface which works well in the Rust context.
That's a research project.
There's, it could be, yeah, and that could be your research project is doing graphics in Rust. The painful part is the first part, right? We're going from nothing to a screen, right? I saw this one video. The guy's was making an NES game, and he was all excited. He's sent a picture of a black screen to his friend, and he was exciting. It's like, it's a blank screen. No, it's a black screen. There's a difference, right? So just getting that first, up and coming, thing is pretty awesome. One thing I really like to do in C++ is use this library called Dear IMGUI, which is a very nifty library for doing cross-platform, graphical user interfaces. So there are some things that we wouldn't get to explore if we didn't do C++, right? But you'd be learning things, I guess, in JavaScript or stuff. Do you want to do graphics in Rust? Not really. He's like, nah. Okay.
I looked into it for myself, and I did a little project for myself with that. I have done some graphics in Rust, but not very low level. There's a whole thing with Rust except they try to expose like super high level APIs, so you don't have to worry about the low level stuff.
Sounds good. Okay. All right. Python?
I like Python. Python is probably, I guess in this case, it's probably going to be just as easy as JavaScript. I would say usually like Python's probably going to be easier than JavaScript. JavaScript does a whole bunch of weird like synchronous stuff, but I think in this case it'll be probably just as easy.
Okay.
That's true, actually. Yeah. I guess even if you're doing an application like that in Python, you're probably gonna set up some event loop, and then like basically you're gonna like be manually writing this asynchronous stuff anyway. So.
Yeah, basically. I mean, yeah. Every graphics application, you're just getting to that main loop where it's handle input, do updates, draw, and it's just a repetitive cycle. Okay. Okay, so I think in this case, we'll just stick with JavaScript. Okay, and if you want to use TypeScript, you can, which is, it basically just compiles into JavaScript. But I will be providing vector classes and matrix classes compiled already from TypeScript into JavaScript. And we'll go from there. Okay, so it makes a difference to know which one to go through, right? And to also critically evaluate which language do you use for a certain project, because it can affect the outcome, right? If you were a game developer, I wouldn't expect Call of Duty to be written in JavaScript. It'd probably be written in C++. And C++ by far is the dominant language used, in the industry, everywhere for graphics, just because it's mostly predictable, and there's a lot of tools already out there for C++. So, and probably to some degree has something to do with the fact that many games are written for Microsoft platforms, you know. So Visual Studio is pretty big. Okay. Yeah. So yeah, we'll use JavaScript, and that just affects it because I'm preparing this crash course, and I'd like to have the mindset. Every language has its own mindset going into it, so this is partially the reason for that. Okay. So I'll be hosting the code up here, everything that we need, essentially. All right. So the very first homework assignment is going to be create a will be to create a graphics application, but we're going to do a special kind of graphics application. All right, and that kind of graphics concept is basically the same one used in ShaderToy, where you basically use a OpenGL shader to write to a texture map, and then you can use that texture map as the input to another later stage, which is different than the normal way of doing it, which is I have a bunch of triangles I want to write, and so you're spending a lot of time organizing, getting triangles rendered off to the screen. Whereas with like ray tracing and so on, it's a little bit different story, because we want to get the advantage of using the hardware, especially now that, you know, hardware accelerated ray tracing is out there. So that's actually what we're going to spend our time doing. So so I'm going to get the homework assignment published here tomorrow, and the YouTube assignment published tomorrow, and then you guys basically just be working through getting a graphics application up and running in a web browser, using the framework that's going to be made for class. All right, and then I just want to talk a little bit about basically how to package up homework to send it to me. So we will. I'll go ahead and just use. We'll use Blackboard for submitting homework, because one nice thing about Blackboard is I can just put your grades in, and then you can, as you're turning in stuff, you can see what your grade is going to be for the class, which I think is helpful. So, yeah, so all the homework will be submitted via Blackboard, and then I'll basically, what you're going to do is, let me see if I have a copy here. Everything's on that laptop. That's a big problem here. Everything's on that laptop. But so here's the basic idea, right? So the homework package is going to be your username, and I guess actually I can pull up the previous homework, the previous graphics class, so you can take a look at what that looks like. So let's go ahead and let's copy that. Yes. Okay, so the idea here is, and I would recommend that you guys install Visual Studio Code. It works on Linux, Mac, and Windows. And if you were in the last graphics class, you're already familiar with the whole setup. But the idea here is we use Node.js to kind of install the TypeScript compiler and install the like linting tools, and a program called Light Server, which basically lets you start a little HTTP server in the current directory. So if I go ahead and open a workspace like this one, no, I'm going to open a folder. Okay, so the idea here is we can just start a server, and a example just happens to be the particular homework assignment, and then when you go into the oh, maybe not. That's just the bare bones. Okay. Anyway, so the idea is that you can work on the code. So under your username, and this is the source code over here. So you can just work on the source code, and then it'll, anytime you save a change to it, automatically tells the browser to refresh everything. So it's a very quick work cycle. Okay. So. But basically, this is what it's going to look like. And so every week, you just add your next homework assignment onto that. Okay? And then next week, when we meet again, we're going to go over how to do this website framework and everything. So you guys can start working on, oh, okay, how do I do WebGL right this weekend? And then we can get all of our stuff ready so that when we start learning about ray tracing, we can start creating a ray tracer from scratch. Okay, now how are we going to learn how to write a ray tracer from scratch? Okay, so let me just first thing is, I don't remember when this class ends. 15 minutes. So that's okay. So the oh, we didn't talk about the book. So I don't. You don't need to buy a book for this class, but there is a free book that we're going to be using, which is called Ray Tracing in One Weekend, written by Peter Shirley, and this is actually a very popular one. So you can actually. It's a series of 3 books. I wonder if he like redid this, but so he does everything in C++ here, okay? And we're going to use this to kind of work on learning how to produce some basic stuff, like, so for one, addressing pixels. Okay, so we'll be learning how to do that, and we'll be talking about our own vector class, which is a little bit different than his, but he goes into a vector class. Start talking about cameras. We're gonna borrow his very basic sky, which is just a blending from white to blue. nothing too fancy. Doing a sphere. So in this case, we're gonna start learning how to ray trace a sphere. And none of this needs to be done with the normal graphics where you send geometry to the pipeline. We can just use a bunch of formulas and say, well, sphere is supposed to be here, sphere is supposed to be here, and we can do everything without having to load data up on the fly, which is kind of neat. And then, let's see here. Talk about anti-aliasing. Materials. So this whole book basically explains a lot of different kinds of concepts that we're going to be going over in our class. So this is probably worth reading, you know, on your own time, but this is kind of where I'm sourcing some of the flow of how we're going to talk about each each particular topic. But we're also trying to combine some of the new stuff, like how do the new ray tracing hardware, how does that work in concept, because it's a little bit different than how you'd write it in C++. Okay. Sure. All right. So this is one of the books that we're going to be using, and this is actually a series of 3 books. Oh, actually, I should put this on the... I think this is his... I think this is everything. Book and everything. So the series, I think, is all in here. So there's actually 3 books to go along with it. I saw these books on Amazon a while ago, and so the cool thing about this is there's 3 of them, and the only thing he doesn't do very well, I think, is that let me click this. It's one of the, let's go back. This one, you know, it's getting into the probabilities and stuff. And some of this stuff, like, it would be nice if he talked about it a little bit more towards the beginning. So I'm trying to find a good picture of what some of this stuff does. Okay, so like being able to do a model like this where it's like the Cornell box, which is a very famous 3D model for testing global illumination algorithms, because you have reflections off the walls and everything. So we're going to try to cover all the 3 books, essentially, because there's a lot of good information there as we're working through the whole ray tracing concept. And then, but we have to learn it in a new way, because when you're programming things with C++, like he does in the books, you don't have to worry about, I'm running a program on the GPU, so how does that look? You know, so, because there's some new concepts there. All right, so just be aware that when you're reading the book, it might be a little more difficult to translate the topics straight from what the book is saying to how do I use this inside my own renderer. And so I'm going to try and make connections from the books to the lectures, so we can kind of get a better idea of how does that, how would you actually do that when you can't just declare variables any way that you want, or do branching the way that you might expect. Because when you're using GLSL, the branching is a completely different concept. You can't just, you know, iterate through a list of things. Everything, you have to know, the GPU has to know where those things are in memory. So like one thing that bit me is, so I'm doing shadow mapping on an NVIDIA GPU, and the shader language is pretty flexible with allowing you to just address things however you want. So I can use a variable, like say, okay, for I equals 0 to 16, so I have 16 lights, and then I call a function with that index to process that light. However, that doesn't just work, okay? Because the function takes an int, but now the shader, when it's getting compiled, doesn't know how to say, well, that's supposed to be index 14. In other words, it wants me to say this is index 14. And so as it's unrolling the loops and everything. So something you might do in a C++ or C where you're indexing things and you just pass the index to a function no longer just works. Or if you're trying to do recursion, which a lot of this stuff is kind of recursive in nature, right? You're sending a light off, okay, bounce it randomly somewhere else, bounce it randomly somewhere else, and just keep doing that until you're getting no contribution. So recursive algorithm on a GPU, it has to know when it's going to stop. So like one thing I ran into writing a GLSL ray tracer is that I kind of had to basically copy the same function several times to do the recursion in a way that it didn't think I was calling the same function over and over again, just because I wanted to get a few bounces of light in a certain kind of way. So there's going to be some, you know, as you're learning GLSL, you're going to get to learn what it can do, what it's capable of, but you'll also run into, you have to like, you have to use it in a way that you have to appreciate that some things will not just work the way you expect it to work. It looks like C, but it doesn't act like C all the time. Okay, so these books are really good. The best part, they're free, so you don't have to pay. It's not an additional cost to use them. The only disadvantage is that you have to like do some translation in your head. Okay, he's talking about this in the book. How is that going to look when I write it in the shading language? Okay, because the shading language, the advantage to that is it's going to run very, very quickly, and so we can basically do real-time ray tracing, which is really, really nice right now. So, trying to set you guys up for success as far as like the current state of the art, you know, when it comes to graphics. Let's see here. And so resources. So a few minutes left. So resources. I don't keep it at the school, but I do have the RTX 2080 Ti. So if we want to get benchmarks on your programs running on an RTX 2080, then we can do that. Which is basically the flagship ray tracing card out there. So we can kind of get some real numbers as far as what is this looking like. I'll probably be running your guys' graphics demos on that. One of the nice things about it is I plugged it in my computer, and normally, which is kind of funny, but normally when you're doing graphics, so let me open up let me load up this one. Okay, so on a Mac, right, I have a Radeon Pro 560X in here, so that's pretty nice. But if you run on Windows, it's going to say Angle because it's using DirectX behind the scenes. So if you're running on Windows, all your OpenGL code is actually being run in DirectX. So it's kind of going through this translation kind of thing, which is kind of interesting. But what's kind of nice is that on the ray tracing card, I can just see the vendors, the RTX 2080 Ti is like, oh, that's kind of nice for doing real-time graphics. So that is a resource that we have available. The other ones are I'm setting up this little GPU cloud. So we have a bunch of these NVIDIA Jetson TX2 boards. So it's a 64-bit ARM architecture running Ubuntu Linux. And what we can do there is, so if like your projects, if you're trying to run a project that's going to be, that you want to see how it works on an ARM system, then we can do that. And I just gotta, when I get everything set up, I'll get all the IP addresses and stuff. So essentially, if you want to log in to one of these machines, then we can go ahead and get that set up. So that'll probably be available in a couple of weeks. So that's a resource. And when it comes to if you compare it to a Raspberry Pi, it's a different performance level because it's got 256 NVIDIA cores on it versus which is pretty fast compared to a Raspberry Pi. So if you want to do some ARM-based research, then we have that available. And what else? I think that's it for now. So I guess I'll open up to questions, concerns. I'm interested in hearing what you guys would like me to kind of go over the semester. If you guys have specific graphics topics that you're really interested in, that I hadn't mentioned before in the kind of on the menu.
Have you done anything with Vulkan?
No.
Do you know what it is?
I do know. So I haven't written a Vulkan program, but I write my graphics applications as if I was going to. The biggest thing there with Vulkan, or even the latest version of DirectX, Direct3D 12, is the concept of you basically set everything up in the context so that when you draw, that's the only thing you're going to do. And the difference there is,
As opposed to,
so the difference is like the classic OpenGL, like, okay, let's just set the color to this variable. Let's go ahead and change this uniform variable and this shader to this one. Let's go ahead and change let's turn off the depth buffer and let's do it this way. But you can like intermix all that stuff as you're doing your drawing. So you're basically telling a server, here's what I'd like to be doing at this moment in time. But what has to happen on the GPU side is it has to essentially say, maybe you make one change to the context and it's benign, it doesn't do anything. It's fast, right? But then you make another change, like I'm just going to switch the shader, right? Switch a program, and then it's got to like rewire everything just to accommodate that one change. But it just looks like one line of C++ code, right? Use program this one. And so what ends up happening is you could make one change to state and then cause the GPU to stall, waiting to catch up on everything that's being asked to be rendered before it'll actually continue going. And so that is not the easiest thing to handle when you're trying to make millions of dollars on a video game or a graphics application. So you basically, so then there's like, okay, now you have to have a lot of wisdom on, okay, it's okay to change this on the fly, it's okay to change that on the fly, it's not okay to do this, it's not okay to do that, in order to squeeze as many pixels per second out as you possibly can. So Vulkan, and so essentially if you like look at the manuals for like OpenGL 3 and 4, they just start getting bigger and bigger and bigger and bigger. And so, you know, which is nice, you get more features, but so the big change is, okay, we can't, this thing is it's going crazy. So instead what you end up having are a few sets of state. So in other words, you basically lump all your state in at once. Okay, you build it all up at once, and then you just say, okay, now we're going to render this set of triangles with this state. And so the idea is that instead of setting all that state individually, you just set it one time, and then you say, we're using this one now. And then you say, okay, now we're using this one now. Now we're using this one now. But it makes the setup code a lot more complex. And especially because it uses these cryptic terms like descriptor tables and, you know, and then you're like, what are they talking about? It's a long, and then the second thing is the shading language, right? So what makes kind of OpenGL and DirectX kind of easy is that you know that, okay, I'm just going to use HLSL or I'm going to use GLSL, write my shaders, and I'm done with it, right? And there's several different shading languages out there, versions out there. So then you have to kind of be in sync of, well, which one am I using for this program and this one? So the other big thing kind of going along with Vulkan is this, it's called SPIR-V, which is this like intermediate assembly language representation of what a shader program is, which is really nice because if you wanted to, now you can write all your shaders in C++ and then use Clang to compile it into SPIR-V, and then you can just use SPIR-V to run on, that'll get compiled into the AMD version or the NVIDIA version or the Intel version, and then that just gets run on the GPU. So when it comes to, I want to get the highest performance, then Vulkan or Direct3D 12 will be like your ticket to doing that. as long as you understand that you have to have everything ready to go. And it's already bad enough that with GLSL, you already have to have a whole bunch of stuff ready to go in exactly the right way, or you don't get any graphics at all. So the reason why I'm not going to teach Vulkan right now, maybe in the future I will, and we'll probably talk about the architecture a little bit. We're going to talk about the architecture because like the new the ray tracing stuff. You know, you have to understand how Direct 3D works essentially. But the biggest thing that you could probably find on Twitter is like, okay, if you wanted to write a WebGL program, you saw we could just like get up and running in just a handful of lines, and now you have to have all this boilerplate just so you could have one triangle on the screen, and really it's just that much more complicated to jump into it. So so what I do instead is we approach WebGL like we're writing a Vulkan program. In other words, I normally make a class with all the rendering state in one area. So when we set a program up, it's going to set the depth buffer, it's going to set the shading program we're using, it's going to set the matrices, it's going to set everything up. So we can just say, okay, now we're going to render the sky. Now we're going to render a 3D model of some kind with certain material settings. So that's kind of how I do it right now. It's kind of like a in-between step, because a lot of times you want to write your own 3D engine to hide all the Vulkan stuff or all the Direct 3D 12 stuff. It's worth doing as a homework. Like you could use that as a homework assignment. You know, go ahead and implement or do a Vulkan program or so. But I'd rather you guys decide that you want to do that than make you do it and be like, we're trying to learn things like ray tracing, global illumination, and I don't want us to get too much in the weeds of my descriptor tables aren't right, man. I don't know what's going on. So that's kind of where we are. Okay, so I think that's it for today. I apologize for this stuff not working out of the box up front. But so next week, hopefully all the bugs will be figured out by then, and I'll get the YouTube down. Okay, so I think that's it for now, and we'll see you guys next week. And I'll send out a message via, I guess, a mass email via Blackboard, letting you guys know the links for all the websites and everything. And then just you'll keep on track. The WordPress site will be the main way for us to get our news, and then also Slack. So, okay. All right. Thank you very much. Anybody staying for the next class? You're staying. You're staying.